Good evening, dear students. मैं पढ़ दो। Yes. Okay. So yesterday we had started with paper solving. Okay, modern question paper solving. So today we will continue with the same. So we have seen in the previous class we have seen the MCQs. Okay. So as you know the paper. Okay. You have the chemistry paper for 70 marks. So we have seen part A, which consists of MCQs, okay, multiple choice questions. So you have 15 questions. So each question, 1 mark. So 15 questions, 15 marks. Okay, so we have seen this in our previous session. Then also we had discussed, so the second question, that is fill in the blanks. Okay, so this is the fill in the blanks part. Okay, so we have seen the fill in the blanks also in the previous session. So you'll be given in your, so you can see here. So in the bracket, okay, some answers will be given. So from that you have to choose the proper one. Okay, you have to choose the correct answer. So these are the 5 questions. So 5 questions, 5 marks. Okay, 5 questions, 5 marks. Fine. So next was part B. Part B, first we have seen the 2 marks question. Okay, so you will be getting 6 questions. Okay, out of 6 questions, you can answer any 3. You can answer any 3. So each question, the marks allotted is 2 marks. So 2 into 3, you will get 6 marks. Okay, so we have discussed these also in the previous session. So today we are going to start with the part C. Okay, what does the part C consist of? So fourth question, okay, answer any 3 of the following. Each question carries 3 marks. So this is a 3 marks question. So again, here also you are going to get how many? 1, 2, 3, 4, 5, 6. So there are 6 questions. Okay. So out of 6 questions, so you have 3 options. Okay. So extra 3 options you have. So out of these 6, you can answer any 3. So correct 3 answers, you will get 9 marks. So each question, the marks allotted is for 3 marks. Okay. So you're going to get 9 marks, the total marks. So we'll start with the questions now. Yes, students, shall we start with the 3 marks questions? Okay, so we'll start with the 3 marks questions. So the first question is, transition metals and their compounds are used as catalyst. Okay, give 2 reasons. So transition, so this is a question from which, this is a question from coordination chemistry. Okay, sorry, transition elements. So this is a question from your D and F block elements. Okay, so this is a question from D and F block elements. So transition metals and their compounds are used as catalysts. So give any 2 reasons. So can you give me any 2 reasons why transition metals and their compounds are used as catalysts? What are the catalysts? What is the role of catalyst? What is the role of catalyst? Yes, what is the role of a catalyst, students? Okay. So catalyst, what it will do, it will increase the rate of reaction. Okay. So it will speed up the reaction. Yes. So what are the 2 reasons? Okay. What are the 2 reasons? So I'll quote down some few reasons. So out of these 4, okay, you can write any 3 reasons. Okay. You can write any 3 reasons for any. So you have to write any 3 reasons. So for each reason, you will get 1 mark. Okay, so I'll change here. You have to write any 3 reasons. Okay, so for each reason, you will get 1 mark. Okay, fine. Okay, so what are the reasons? Okay, the first point is variable oxidation state. Okay, so transition elements, transition metals, you have seen that there are different transition metals. Okay, and these transition metals, they will show variable oxidation state. Okay, so transition elements are having variable oxidation state. So this is the first property. Then the second one is what? Presence of vacant d orbitals. Okay, so there is a presence of vacant d orbitals. So vacant d orbitals. So this is a second reason. Presence of vacant d orbitals. Okay, then the third reason is what? Formation of intermediate compounds. So transition metals and their compounds, they are used as catalyst because of formation of intermediate compounds. Okay, so these metals can form intermediate compounds. Yes. Okay. Fourth one, it provides large surface area for absorption of reactant molecules. Yes. Okay, many have answered the same point. Yes, Dhanush, Vedvati, yes, Vedvati, Dhanush, yes, all the points are correct. Yes, so these are the reasons you have to mention. So any 3 reasons. So for each reason, you will get 1 mark. Okay. So like this, the marks are distributed. Okay. Moving for the next question. Describe the preparation of potassium permanganate from MnO2. Describe the preparation of potassium permanganate from MnO2. Yes. So describe the preparation of potassium permanganate from MnO2. Okay, so the first step, so you know that we have seen this, okay, while solving the, when we are discussing the each chapter, so that time we have seen this in DNF block element. Okay, so preparation of potassium permanganate. Okay, so first step is what? MnO2 is fused with KOH. Okay, MnO2 is fused with KOH and potassium nitrate, and it gives you potassium manganate. So the first step is 2 MnO2 plus 4 KOH, okay, plus oxygen, giving you 2 K2 MnO4 plus 2 H2O. So this is the first step. Okay, this is the first step. What we are doing? We are fusing the MnO2 with KOH and potassium nitrate. Okay, and you get potassium manganate. What you get? Potassium manganate is for which is green in color, which is green in color. Now, what is the second step? What is the second step, students? So the second step is, what is the second step? This potassium permanganate. Okay, this is a neutral or acidic solution. Okay, in neutral or acidic solution, it will give you permanganate. So 3 MnO4 2 minus plus 4 H plus, giving you 2 MnO4 minus plus MnO2 plus 2 H2O. Okay, so this is the second step. Or by electrolytic oxidation of manganate, it gives you permanganate. It is MnO4 2 minus. Okay, when it undergoes electrolytic oxidation, when it undergoes electrolytic oxidation in alkaline solution, gives you MnO4 minus. What it gives you? MnO4 minus. Okay, so these are the steps to be written, okay, for this question. Let us describe the preparation of potassium permanganate from MnO2. Is it clear? Is it clear? So these proper equations, okay, with a bit explanation. So you will get 3 marks. Okay. So next question. So 3 marks question is divided into two. You can see sub question A and sub question B. Okay, what is the sub question A? Give any two differences between lanthanoids and actinoids. Okay, so what is the way to write? So you have to do two columns. Okay, lanthanoids and actinoids. So like you have to write like this two columns, and then you have to write the each differences. Okay, so what is the difference in lanthanoids? So 4f orbitals are progressively filled. Okay. So lanthanoids here, the 4f orbitals are filled. Okay. Progressively filled. And actinoids, 5f orbitals are progressively filled. 5f orbitals are progressively filled. Okay. Lanthanoids, these are less reactive. Okay. Lanthanoids are less reactive. Actinoids are more reactive. Are more reactive. So for each proper difference, you will get 1 mark. So either side, it should be correct. So on both the side, it should be correct. So if your one side is wrong, then the complete will be wrong. Okay, 1 mark will be deducted. Second point, if it is correct, you will get only 1 mark. If both the points are correct, you will get 2 marks. So both on the both side, when you are writing the differences on the both side, it should be correct. Okay, the point should be correct. So these are the two differences. Okay. Next one. Manganese exhibits a maximum oxidation state of +7. Give reason. What is the reason why manganese uh, exhibit this +7 oxidation state? So, what is the reason? Okay, why manganese exhibits Mn? Okay, manganese is Mn, exhibit +7, maximum of +7 oxidation state is due to the participation of all the electrons of 3d electrons and 3d and 4s orbitals in bonding. Okay, please note this down if you don't know. Due to the participation of all the electrons of 3d and 4s orbitals in bonding. This should be the answer. What is the answer? Due to the participation of all the electrons. So Mn, when you are writing for Mn, so the electrons which are involved in 3D and the 4s, so all the electrons are involved. So okay, so Mn is what? Mn is 25. So it is 3d5 and 4s2. Okay, argon 18, 3d5 and 4s2. So when it undergoes Mn plus 4, so that time all these electrons are involved. Okay, so 3d electrons as well as 4s electrons are involved. So, because of this reason, okay, maximum oxidation state shown by manganese is +7. Okay, okay. Next question. So if you did not understand anything, if you have any doubts, please you can ask me in the chat box. Okay, you can drop your message in the chat box and you can ask me that. Okay. Next, 30th question. Next is 30th question. So again, this is divided into two sub question, A and B. Okay. Sub question A, draw cis and trans draw cis and trans isomer of uh, this is a complex of platinum. Okay, how do you write the cis and trans complex? So what you have to write? Okay, platinum in the center. Okay, then when the ligands are on the adjacent side, okay, then they are called as cis. Okay, and when they are on opposite side, okay, when it is in opposite side, trans. Okay, so this is the cis and trans. Okay. So, this is a 2 marks question. So for each this structure, you will get 1 mark. So this is a cis form. So the ligands are on the adjacent side. Okay, they are on the adjacent side of the central metal atom. Okay, so this is a cis, and when the ligands are on the either side opposite to each other, then it is a trans. So for each structure, you will get 1 mark. So this is a 2 mark question. Okay, next, give the IUPAC name of. So this is a complex. Okay, you have to give the IUPAC name. So can you give the IUPAC name of this particular compound? Yes. Can you tell the IUPAC name? What is the IUPAC name? Can you tell me the IUPAC name of the complex? Yes, students, try. So this is a 1 mark question. Okay, you can see. So this is a question asked from coordination chemistry. So in 3 marks question, you can see these are the questions, okay, from inorganic chemistry, right? So these are the questions from inorganic chemistry. Okay, inorganic chemistry, you have 2 chapters, that is D and F block elements and coordination chemistry. So from this chapters, this 3 marks questions you will get. Okay, and 2 marks questions, they are mixed. 2 marks question, they will be mixed. Okay. Okay, can you tell me what is the IUPAC name? Yes, students, try. Okay, so I'll tell you how to write the IUPAC name. Okay, so first, okay, so there are ligands. Okay, this is a amino amine. Okay, it is a what ammonia. So the this ligand name is amino. Okay, so amine. Okay, so this is a amine. Then bromo. So B comes bromo. So which comes first? A comes first or B comes first? A comes first, right? So how many are there? 5. So it is pentaamine. Okay, pentaamine. Next comes your bromo. Then comes your bromido, pentaamine. Pentaamine, bromido. Okay, then cobalt. What is a complex charge? It is 3. The charge on cobalt is 3, and outside is your sulfate. Then comes your sulfate. So this is the way of writing the name. So pentaamine, bromido. Okay, cobalt 3, sulfate. Understood? Okay, so this is the way you have to name it. Is it clear? Yes. Any doubts? Okay. Moving forward. Next question. So 31st question. Using PBT, account for the geometry and magnetic property of, okay, tetracyano nickel, okay, 2 minus 2 complex. Okay, so this we have seen in our previous session when we were discussing the what chapter your coordination chemistry. Okay, so there we have discussed about this complex. So based on the VBT. So what are the things? First, you need to write the electronic configuration of nickel. So as you know, so I'll just going to write, okay, because we have discussed previously. So just see, then electronic configuration of nickel, then electronic configuration of nickel in +2, okay, because when you see the oxidation state of nickel, it will be +2. So it will be argon and 3D8, 4s, 0. So when you write this and 4s. So this is 3D, this is 4s. So it will be 1, 2, 3, 4, 5, 6, 7, and 8. Okay. So now in the presence of, which is the ligand? In the presence of Cn minus, okay, this is what the electron pairing will takes place. Okay, the electron pairing will takes place. Now what will happen? So 1, 2, 3, 4, 5, 6, 7, and 8. Okay, and this will be empty, 4s. And 4p also will be there. Okay, so how many ligands? 4. Okay, so how many you require? 4 blocks. So I'll take another color. So here one. So from 1, 2, and this. Okay, so it is DSP2. Yes, DSP2. So what is the hybridization? So you have to mention hybridization is DSP2, DSP2. Then what is the geometry? Okay, this what is that? Your sino. Okay, they will occupy the four corners of the square planar complex. Okay, so they will corner and a nickel will be at the center. So it is a square planar. What it is? It is a square planar. And what is the magnetic behavior, students? It is, or you can see that there is absence of unpaired electron. So it is a diamagnetic. You can see it is a diamagnetic. So this is the things you have to write. Okay, is it clear? So out of the 6 questions, you can attempt any 3. Whichever you are perfect, okay, that you can answer. So you will get 9 marks. So each question 3 marks. Okay. So last question, 32 question for from 3 marks question. For a given complex, so this is a complex, mention the primary and secondary valency of cobalt. What will be the geometry of the complex for a given complex? So this is a complex given. Okay, you have to tell the primary and secondary valency of cobalt. Yes. What is the primary valency? Primary valency of cobalt. For a given complex, mention the primary and secondary valency of cobalt. What will be the geometry of the complex? Yes. Secondary valency means, okay. See, primary valency tells you about what. What does primary valency? What is the difference? What is the difference between primary valency and secondary valency, students? First, see that. Okay, if you are getting confused between the questions, so first understand what is the difference between the primary valency and secondary valency. Yes, students, what do you mean by primary valency? What do you mean by secondary valency? Primary valency. Yes. Try to answer. Difference between primary and secondary valency. So when we are talking about primary valency, what does it mean? The number of this negatively charged ions, okay, negatively charged ions, which is equal to the charge on the core ion. It is the primary valency. What is secondary valency? The total number of ligands which are coordinated to the central metal ion. So here, the primary valency of cobalt, it will be +3. Okay, it is what? It is +3. And the secondary valency of cobalt is what? It is 5 plus 1. It is 6. Okay, it will tell you the coordination number. Okay. And what is the geometry? When it is 6. Okay, secondary valency is 6. So the geometry is octahedral. The geometry is octahedral. So for each correct this, you will have 1 mark. So this is amino. Okay, this is 3. You have to mention this as 3. So if I see here, okay, cobalt, amino, NH3, 5, then NO2, Cl2. Okay. Now here, cobalt is X minus. Okay. Then this is 0 minus 1 equals to -2. So X minus 1 equals to -2. This becomes +1. This is the charges -2. This becomes -2. This will also go that side. -1 becomes 3. So the charge is 3 here. Okay, and the secondary valency is 6. Okay, so the geometry will be octahedral. Okay, like this. So for primary valency, if you write correct primary valency, 1 mark. For secondary valency, 1 mark. And for the geometry, 1 mark. Is it clear? So so this is a part C. So part C, it comprise of what? It comprise of inorganic chemistry. It consists of inorganic chemistry. Okay. And so you will be getting 6 questions. So out of 6 questions, you can answer any 3. Is it clear? Yes. Is it clear? So we'll move next. Okay. Answer. So in the part C only, fifth main question. Answer any 2 of the following. Each question carries 3 marks. Okay. So here you are going to get 1, 2, 3, 4. So 4 questions. So out of this 4 questions, you have to answer any 2. Okay. So this part you will get it from okay, so this part, okay, you will get it from what? You will get it from physical chemistry. Okay, you are going to get these questions from physical chemistry. Okay, so you are going to get 4 questions. So out of 4 questions, uh, you have to answer any 2. Okay, so physical chemistry, you have 3 chapters: electrochemistry, chemical kinetics, and solution chapter. So out of that, you will get any. Okay, out of 4, you'll get any 2. You have to write any 2. Okay. So so each question 3 marks. So 3 into 2, 6 marks. So we'll see the first question, 33rd question. What? So this is divided into uh, A, B, A and B. Okay. So what type of deviation is expected from Raoult's law when equal volume of two liquids is mixed okay, the temperature of resulting solution decreases. And in that second question, 10 ml of liquid A is mixed with 10 ml of liquid B. The volume of the resultant solution is 19.9 ml. And B question, give an example of maximum boiling azeotrope. Yes, what is the answer for that? Yes. So what type of deviation is expected from Raoult's law when equal volumes of two liquids is mixed and the temperature of resultant solution decreases? Yes, what type of deviation is observed when you see? Yes, good. Yes, Vedvati has answered. It is a positive deviation. Okay, it is a positive deviation. And 10 ml of liquid A is mixed with 10 ml of liquid B. The volume of the resultant solution is 19.9 ml. So what you can see, what is happening here to the resultant? What will be the deviation seen here in this case? What will be the resultant seen in this case? What will be the resultant? It will be a negative deviation. Okay, it will be a negative deviation. Okay, give an example of maximum boiling azeotrope. Can you give me example of maximum boiling azeotrope? What is the example for a maximum boiling azeotrope? It is, what is it? It is, you can take it down, 68% nitric acid, 68% nitric acid plus 32% water. Okay, so please remember all this examples. Okay, very important. Okay, so for the this one you will get 1 mark. Okay, here 1 mark and here 1 mark. So like this, the 3 marks are divided. Okay, you'll sometimes in organic chemistry, inorganic chemistry only direct questions are asked. Okay, physical chemistry, you will be getting splitted questions. Okay, can you see how it is splitted? So like this, the questions are splitted. Okay, now moving forward. Next question. What is molar conductivity? Give its SI unit and how it is related to conductivity of a solution whose concentration is C mole per meter cube. What is molar conductivity? Okay, so for this you will get 1 mark. Its SI unit 1 mark and how it is related to conductivity of a solution whose concentration is C mole per Yes. What do you mean by molar conductivity, students? What do you mean by molar conductivity? Conductivity of a solution containing 1 mole of the electrolyte. Okay, so this word should come. It contains 1 mole of electrolyte. So conductivity of a solution, okay, containing 1 mole of the electrolyte. Conductivity of a solution containing 1 mole of the electrolyte is molar conductivity. What is the SI unit? It is Siemens meter square per mole. Okay, Siemens meter square per mole. I hope you are writing this. Okay, if you don't know, please make it note. So conductivity of a solution which contains 1 mole of the electrolyte is molar conductivity. And what is the SI unit? It is Siemens per meter. Okay, per mole. And how this is related? So is equals to K by C. So how the conductivity is related? Okay, it is given as this. Okay, so you can note it down. Next question, draw a neat label diagram of H2O2 fuel cell and write its cathodic and anodic and overall cell reaction. Write a labeled diagram of H2O2, that is water. Okay, H2O2 fuel cell. And you have to write the cathodic and anodic cells. So how the diagram will be, just see. Okay, so from here, water outlet, this is a cathode. Cathode means plus. And here will be the inlet. H2. O2. Okay. And what is filled here? Here will be your aqueous electrolyte. Aqueous electrolyte. So these all things should be written. Okay. You have to uh, label it. Okay. You have to label. So it should be a labeled neat diagram. Okay. So these all things, it should be maintained. Okay. Now, so the cathodic and anodic reactions. So cathodic reactions, O2 plus 2H2O plus 4 electron giving you 4 OH minus. So this is a cathodic reaction. And anodic reaction is 2H2 plus 4 OH minus giving you 4H2O plus 4 electrons. So this is a anodic reaction. Okay, and what will be the overall reaction? Overall reaction is 2H2 gaseous plus O2 gaseous giving you 2H2O liquid. Okay, so these are the things you have to mention. So these for writing the proper diagram with the label thing, and these cathodic and anodic overall cell reaction, you will get 3 marks. So out of 4 marks, 4 questions, you have to answer any 2. You have to answer any 2. Is it clear? Yes. Okay. Last question. Derive an integrated rate equation for the velocity constant of first order reaction. So this is a question from chemical kinetics. So we have seen this. So you have to derive the first order reaction. Okay, so you know the steps. So I'll not write it again. Okay, first order reaction, we know all the steps. So you have to write the rate equation. Okay, and then integrate it. Then find the value of I, integration constant, add it, substitute it, and then you have to rearrange and get the final equation. So the final equation is K is equals to 2.303 T log of R naught by R. Okay, so this is the, you have to, it should come. Okay, so this is the first order reaction. Okay, so so out of this 4, you have to answer any 2. Is it clear? So you will get, so out of this 4, you have to answer any 2. Okay, so you will get 6 marks. So 3 marks each question. Okay, moving forward, part D. Okay, part D consists of again your 6th and 6th. Okay, so here how many questions are asked is 8 questions are given. 1, 2, 3, 4, 5, 6, 7, and 7 questions are there. Okay, 1, 2, 3, 4, 5, 6, and 7. So 1, 2, you have to write any 4. So out of 7, you have to write any 4. Okay, out of 7, you have to write any 4. So each question will carry, so this is a 5 marks question. So part D is of organic chemistry. So this is organic chemistry. Okay, so this part D will completely from organic chemistry. You will get questions for organic chemistry. So 20 marks. If you are good in organic chemistry, so directly 20 marks you can get from this part D. Okay, so we'll start with the questions. So 37th question, write the of hydrolysis of 2-bromo 2-methyl propane. Okay, B question, name the product formed for the reaction of isopropyl iodide on alcoholic KOH. And second question in B, what is the condition to be satisfied for a compound to be chiral? And D, what is racemic mixture? So this complete question is for 5 marks. This is 5 marks. So as I have discussed from the first class itself, you will not get directly 5 marks question. Okay, in organic chemistry, directly 5 marks question is not asked. Either 2 plus 2 plus 1 or 3 plus 2 or 4 plus 1. Like that, the question is distributed. Marks are distributed. So directly 5 marks question you won't get. Okay, you have the marks are further distributed. So what is the question 37th A? What is 37th A? Yes. So 37th A, what type? It is a SN1 mechanism. Okay, they have mentioned here SN1 mechanism. Write the equation. Okay, what are the steps involved, students? So CH3, CH3, I'll write it here. So CH3, 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 Br. So this is your 2-bromo. Okay, so 1, 2, 3. So 2-bromo, 2-methyl propane. Okay, so so this is the what is the first step? First step is a slow step. Okay, formation of carbocation and a bromide ion. Okay, and it yields into a tertiary carbocation. So it yields into a tertiary carbocation. So you have to explain and you have to mention the steps. So first step. Then second step. What is the second step? Second step is attack of nucleophile. Attack of nucleophile. So CH3, CH3, CH3 plus OH minus. So there will be attack of nucleophile on the carbocation. Okay, and you get what? You get a tertiary alcohol, tertiary butyl alcohol. So this is a product. Okay, so this is a two-step reaction. So first step is a slow step. It undergoes ionization. Okay, it undergoes ionization and what it forms and okay, and it gives you a tertiary butyl carbocation. Okay, and this carbocation is a planar structure. Then second step is the attack of a nucleophile on the carbocation. Steps, okay, simple explanation and 2 steps should be written. Okay, next question. Name the product formed for the reaction of isopropyl iodide on alcoholic KOH. What is the answer? Isopropyl iodide on alcoholic KOH. What will be the product form, students? What will be the product, students? It will be propene. Okay, the answer is propene. Okay, then what is the condition to be satisfied for a compound to be chiral? What is the condition to be satisfied for a product chiral? Yes. What is the condition to be satisfied for a compound to be chiral? So for a compound to be chiral, okay, there should be a chiral carbon atom. There should be a chiral carbon atom. Then there should be absence of symmetry. Okay, there should be no presence of any symmetry in their molecule. Okay, means there should be no plane of symmetry. Okay, and these all other symmetry should not be center of symmetry. So these symmetry should not be present. Okay, so for a molecule to be chiral, so these conditions should be satisfied. Next, what is racemic mixture? What is racemic mixture? What is racemic mixture? If a mixture containing two enantiomers in a equal proportions, okay, that is equimolar mixture of D and L isomers if they are present, then they are called as racemic mixture. Example, what is the example? Plus or minus lactic acid. Okay, plus or minus lactic acid. So, complete this question, you will get 5 marks. Okay, completely this question, you will get 5 marks. Okay, is it clear? So for this, you will get 2 marks. Your 1 mark. This is 1 mark, and this is 1 mark. Okay, so like this, the question is divided. Okay, next question. What is the mechanism of acid catalyzed dehydration of ethanol to ethane? Write the mechanism of acid catalyzed dehydration of ethanol to ethane. And name the oxidizing agent used to convert primary alcohol to aldehyde. Write equation. So this particular question, so your 4 marks and your 1 mark. Okay, so what is the mechanism for acid catalyze? What are the steps? So first is what? First is the formation of protonated alcohol, right? You know that. First step is a formation of protonated alcohol. Okay, we are this. So if I write the structure, so C H H C H H O H plus H plus. Okay, so this will attack and okay. So this is what? Protonated alcohol. So this is a first step. Understood? Then second step is what? There will be this water molecule will be lost. Okay, water molecule will be lost. So I'll erase here. So as there is no space, I'll do it here only. So from this step only, there will be, so this is a slow step. So this is a slow step. Okay, and what will happen here? There will be loss of water molecule. So H, C, H, H, and plus. So water molecule will be lost here. Now, what will happen in the third step? So this is a second step. Now, third step. What is the third step? So C, H. Yes, what will happen, students? There will be elimination of proton. There will be elimination of proton, and it forms a okay, ethene is formed. So we are converting the ethanol to ethene. So this is the reaction. Is it clear? So for the mechanism, you will get 4 marks. So for the mechanism, you will get 4 marks. So write the mechanism for conversion, okay, of acid catalyzed dehydration of ethanol to ethene. So these steps should be written. Now name the oxidizing agent which is used to convert primary alcohol to aldehyde, which is the oxidizing agent. Yes, we have discussed this. I think this we have discussed. Yes, no, we did not discuss. So from primary alcohol to aldehyde, we are making use of CrO3. Okay, that is chromic acid. So chromic acid is the oxidizing agent which is used to convert primary alcohol to aldehyde. So to write the equation and also write the equation. So, okay, so for the mechanism, it will be 3 marks, and for this, you will have 2 marks, because for naming the oxidizing agent, 1 mark, and to write the equation, 1 mark. Okay, so for 3 steps of mechanism, 3 marks. So any one step, if it is wrong, it will be wrong. So first step you have to write. So if the first step is only wrong and your second and third step is correct, marks won't be considered. Okay, everything will be wrong. So please write the positive signs and all should be written properly. If you miss anything, marks will be deducted. Next question, 39th question. How does phenol react with concentrated nitric acid? Give equation. Yes. How phenol react with concentrated nitric acid? What will be the product form? So this is a phenol. Phenol reacting with nitric acid, concentrated nitric acid. Okay. What you will get? What will be the answer, students? Try answering. Yes. What will be the answer? It will be picric acid. Okay, you will get picric acid. So you will get picric acid. So NO2. So it is what you will get 246 trinitrophenol. Okay, so the name is picric acid. What you will get? Picric acid. So this is the reaction of phenol with concentrated nitric acid. What will be the equation? The equation for equation, and this is the what final product 246 trinitrophenol. Then what is a B? Write equation for the preparation of tertiary butyl methyl ether by Williamson's reaction. Okay, so this is 3 plus 2 marks. This is what? 3 plus 2 marks. Okay, so here again, how so it is 3 plus 2 marks. Now, so this is for 3 marks and this is for 2 marks. Okay. Now, how will you prepare tertiary butyl methyl ether by Williamson ether synthesis? So for Williamson ether synthesis, one should be a sodium butoxide you have to take. So I'll take the compound as CH3, 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 ONA. Okay, and plus react it with methyl chloride. So this will react here, and what it will form? It will form CH3, C, CH3, CH3, O, CH3 plus NaCl. Okay, so what is the product from here? Tertiary butyl methyl ether. So tertiary butyl, so this is a tertiary butyl group. This is a methyl group and it is a ethyl. So tertiary butyl methyl ether. Is it clear? Yes. So you will get 2 marks here. So this is the equation. So this is the equation for the preparation of tertiary butyl methyl ether. Okay. Moving forward. Next question, 40th question. Explain Carinzaro reaction with an example. Okay. And B question, phosphorus plus tin chloride, phosphorus plus tin chloride plus HCl giving you, okay, plus H3 plus H3O plus giving you Q. Okay, so you have to identify your P and Q. Identify P and Q. Yes. Can you and see the lower members of aldehydes and ketones are miscible with water? Give reason. So this is a question for 2 plus 2 plus 1. 2 plus 2 plus 1. So first question, explain Carinzaro reaction. So what is the explanation? When aldehyde which do not contain alpha hydrogen reacts with concentrated alkali, it undergoes self-oxidation and reduction and gives you alcohol and carboxylic acid salt. So what will be the equation? So if I give you example, so 2 formaldehyde, okay, in the presence of NaOH, which is a concentrated, gives you methyl alcohol, okay, plus a sodium formate, okay, and sodium formate. So you have to name here. So this is a methanol and this is sodium formate. Sodium formate. Okay, so these are the so for explanation 1 mark and for the equation 1 mark. Okay, next. So what is P? Identify P and Q. What is P? This is imine formation. Okay, this is imine formation. So intermediate form is imine. So what will be the product? So P is your nitrile group. So PC nitrile. So this is P will be your nitrile group and Q is your aldehyde. So when nitriles, okay, when you react it with tin chloride in the presence of HCl, you get an intermediate which further hydrolysis give you aldehyde. Okay, on further hydrolysis gives you a aldehyde. Okay, next, the lower members of aldehydes and ketones are miscible with water. What is the reason? Why the lower members of aldehydes and ketones are miscible in water? Means they are dissolved in water. What is the reason? Why the lower members of aldehydes and ketones are miscible in water? Because they form hydrogen bond. Okay, because they form hydrogen bond with water. Because they form hydrogen bond with water. So because of this, okay, so they are, so the lower members of aldehydes and ketones, they are miscible in water because they form hydrogen bonds with water. Because they form what? Hydrogen bonds with water. Okay. Next, 41st, okay, 41. What is the action of ammonia on benzoic acid? Write equation. B. Write equation for the conversion of ethanoic acid to monochloroethanoic acid, or explain HBZ reaction with an example and give the IUPAC name of this compound. Okay. So this also question, how it is divided. This question is divided as 2 plus 2 plus 2 plus 1. Yes, again, this question is also divided as 2 plus 2 plus 1. Okay, fine. So what is the action of ammonia on benzoic acid? How is the action of ammonia on benzoic acid? So I'll write the reaction. So benzoic acid is what? Benzene with a carboxylic group. Okay, COH. So when it reacts with ammonia, what is formed? Ammonium benzoate is formed. What is formed is ammonium benzoate. Okay, ammonium benzoate is formed. COO minus NH4 plus. This on further heating, okay, you will get benzamide. What is formed? Benzamide is formed. CONH2. Okay, benzamide is formed. So this is the action of ammonia on benzoic acid. So benzoic acid, when it reacts with ammonia, you get ammonium benzoate. What you get? Ammonium benzoate. So this ammonium benzoate, when you heat it, you get benzamide. What you get? Benzamide. Okay. Now, second one is write the equation for the conversion of ethanoic acid to monochloroethanoic acid, or explain HBZ reaction with an example. Now, what is HBZ reaction? It is Hell-Wohlhard-Zelinsky reaction. So, this is a reaction where you are taking the carboxylic acid, okay, which is having at least alpha hydrogen. So, this alpha hydrogen carboxylic acid, when you treat it with chlorine or bromine, you have to take either chlorine or bromine in the presence of red phosphorus. In the presence of red phosphorus, it will give you alpha halocarboxylic acid. Okay, and this is called as Hell-Wohlhard-Zelinsky reaction. So I'll write the example. So I'll write the example here. So it is RCH2COOH in the presence of X2, okay, or red phosphorus, okay, and water. It gives you RCHCOOH X. So X is equals to Cl and Br. So alpha is halocarboxylic acid. Okay. So alpha is that is this is a alpha halocarboxylic acid. So at your alpha carbon you have halogen substituted group. Okay, you have a halogen substituted group. Okay. Now They have also asked you for a conversion of ethanoic acid. So either you can explain the conversion or you can explain the HBZ. So I'll show you ethanoic acid to monochloroethanoic acid. So it will be CH3COOH. Okay. In the presence of chlorine and red phosphorus, you will get what? CH2Cl and COOH. So it is a monochloroethanoic acid. Is it clear? Yes. Next, what is the IUPAC name of this compound? What is the IUPAC name? So it is 1, 1, 1 and 2. Okay, so it is what? What is the name, students? 1, 2. So it is prop, 2-in and al. Prop, 2-in, al. Okay, in because of double bond and al is for aldehydic group. Okay, so this is again 2 plus 2 plus 1. Okay, next question 42. Explain Hoffman bromamide degradation for the preparation of aniline. Next question, B question. Arrange the following. Arrange the following in the decreasing order of their basic strengths in the aqueous medium. Give one reason. And name the major product formed when nitrous acid is treated with aniline at low temperature. Yes. So what is the Hoffman bromamide degradation? So when benzamide is treated with bromine and alcoholic KOH, it gives you aniline. Okay. So how will be the reaction? So this is a benzamide, CONH2. So benzamide, when you treat it with bromine plus 4 KOH, that is alcoholic KOH, it gives you aniline. Okay, it gives you what? Aniline, NH2 plus 2 KBr plus K2CO3 CO3 plus 2 H2O. Okay, so this you have to mention. Okay, so benzamide, when you treat it with bromine and alcoholic KOH, it gives you what? It gives you aniline. It gives you aniline. Understood? Okay. Arrange the following. So what is the, when you arrange it, how will you arrange it in the decreasing order? So first will be your CH3 twice NH, then will be your CH3 NH2, then will be your CH3 thrice N. Okay, so what is happening here? Due to inductive effect, solvation effect, and steric hindrance. So this is the decreasing order of their basic strength. So what is the reason? So you can write any one reason. You can write inductive effect. Okay, you can write inductive effect, or you can write solvation effect. You can write solvation effect, or you can write steric hindrance, or you can write steric hindrance. So any one of the reason you can give. And what is a major product when nitrous acid is treated with aniline? What is a major product when nitrous acid is treated with aniline? So this is aniline and nitrous acid is HNO2. That is when sodium nitrate and HCl reacts, you get nitrous acid. So what is this? You will get benzene N2Cl. That is what? Benzene disonium chloride. Okay, BDC. Okay, that is benzene disonium chloride. So that is the product obtained. So major product obtained is the benzene disonium chloride. So again, 2 plus 2 plus 1. Okay. Last question in organic chemistry. Name water soluble and water insoluble components of starch. So what are the water soluble component? The water soluble component is amylose. The water is component is amylose. And what is the water insoluble component? It is amylopeptine. Amylopeptine. pectin. Okay. Then what are hormones and give examples? What are hormones? Hormones are protein secreted in endocrine glands. Okay. And they enter directly into the blood. So what are the examples? The examples are insulin, glycogen, and oxytocin. So what are hormones? Hormones are proteins secreted in endocrine glands which enter directly into the blood. So what are the example? Insulin, glycogen, and oxytocin. Okay. Now name the vitamin whose deficiency causes scurvy. Yes, which is the vitamin whose deficiency causes scurvy? Vitamin whose deficiency causes scurvy. Yes, it is vitamin C. Okay, vitamin C. Okay, so because of deficiency of ascorbic acid. Okay, yes, correct. So it causes deficiency, which causes scurvy. Okay, so these were the questions. So out of 7 questions, you have to write any 4. So each question is for 5 marks. So 5 into 4, 20 marks. Okay. So for correct answer properly, so there are many options. So you can utilize the options and whichever proper answers you know, so that you can write. Next question, part E. So part E is problems. Okay. So 7th question, answer any 3 of the following. Each question carries 3 marks. So here the number of questions given are 1, 2, 3, 4, 5, and 6. So 6 questions are given. Okay. So 1, 2, 3, 4, 5, 6. So 6 questions are given. So out of 6 questions, you can answer any 3. So again, each question is for 3 marks. So this is a completely the part for physical chemistry. So you'll get questions here from solutions, chemical kinetics, and electrochemistry. Okay, so this is the physical chemistry part. So we'll see the questions now. 44th question. The vapor pressure of pure liquids A and B are 450 and 700 of Hg respectively at 350 Kelvin. Find out the composition of the liquid mixture if total vapor pressure is 600 of Hg. Also find the composition of vapor pressure. Yes, how will you solve this? So I'll solve it here. First question. Okay. So vapor pressure of pure liquids A and B are given as 450 and 700 of Hg respectively at 370 Kelvin, 350 Kelvin, sorry. Find out the composition of the liquid mixture if the total vapor pressure is 600 of Hg, and also find the composition. So we have the vapor pressure equations. Okay. So of pure component A and pure component B. So this will be Pb into so, but you know that, but as you know, okay. So partial total vapor pressure is equal to Pa plus Pb. Okay. But you know that XA is equals to 1 minus XB. So after solving this, so we have to use this that is P total is what? PA plus PB. Okay, what is PA now? PA is XA plus PB into XB. So just PA, then take 1 minus XB, okay, plus P dot XB, then P naught A, that is of pure component, minus, so my 1 minus XB, okay, we are taking it at P naught A into XB plus P naught B to mole fraction of P. So P total is given as P naught, okay, pure component A plus mole fraction of B into mole fraction of partial pressure pure component of B minus A. Okay, so after substituting, what is the partial pressure total is 600. So total vapor pressure is 600. So and the pure liquids A is 450 plus we don't know the partial pressure of B, okay, and we know the pure liquid B, okay, vapor pressure of pure liquid B is 700 minus 450 again. So after substituting this, you will get 150 is equals to 60 into 250. So again, partial mole fraction B is equals to 150 by 250. This will get it as 0.6. But you know that mole fraction of A is equals to 1 minus XB. Okay. So 1 minus XB is what? 0.6. So it will be 0.4. So XA, that is mole fraction of A is 0.4. Okay. But you also know that your this is equals to P naught A into mole fraction of A. That is 450 into XA is what? 0.4. So that will be 180 mm of Hg. Okay. And now in and also for that is partial vapor pressure of B is equals to P naught of B into mole fraction of V. So that is 700 into 0.6. So that will be 420 mm of Hg. Okay. So now in vapor pressure. So when we know the vapor pressure, so they have told to find the composition of vapor pressure. So composition of vapor pressure, now we have to find. So now in vapor pressure. So YA is equals to PA upon PA plus PV. Okay, so what is PA is 180. Here we have got 180. Then PA is 180 plus 420. So after solving, you will get it as 0.3. So again, vapor pressure, okay, in is YB is equals to 1 minus YA. So it is Y1 minus Y is 0.3. So this will be 0.7. So vapor pressure. So the composition of vapor pressure clear. Yes. Did you all get this? Did you solve? Are you getting the same? I hope you are getting the same. Okay. So the vapor pressures of the pure component liquids A and B are given, okay, at a particular temperature, and we have to find out the composition of liquid mixture. The total vapor pressure is also given, okay. So we have the equation. So by rearranging, we have got this. Yes, is it clear? So this is a question from solutions, right? Okay. So moving forward, next question. So the next question is addition of 0.643 gram of a compound to 50 ml of a liquid. Density is given as 0.879 gram per ml. Lowers the freezing point from 5.51 degrees Celsius to 5.03 degrees Celsius. Calculate the molar mass of the compound. Kf for the benzene is 5.12 Kelvin kg per mole. Okay. So we'll solve this now. So please simultaneously you also solve. Okay. We'll verify the answers. We'll verify the answers. So so first thing, as I always say, so please write the given things. So whatever the given things are there, that you have to write down. So what all is given? Kf value is given. Okay, so that is 5.12 Kelvin kg per mole. Okay, then the weight of W2 is given, that is weight of the solute is given is 0.643 grams. Then delta TF value is that is the temperature freezing point is from 5.51 to 5.03. So 5.51. So delta TF can be found out. So the delta freezing point, okay, so the delta TF is 0.48 degrees Celsius. Then volume of solvent, what is the solvent used here? The volume of solvent, okay, benzene. The benzene is the solvent used and it is 50 ml. It is 50 ml, 50 ml. Then density, what is the density given? Density also we have, so that is 0.879 gram per ml. Okay. Okay, so these are the Riemann factors. Now what we have to find? Now we have to find first the mass. We have to find the mass. Okay. So we have to find the mass of the solvent, right? So how do we find the mass? We have density, we have volume. So density is equals to volume by, mass by volume. So mass is equals to volume into density. So what is volume is 50 ml and density is 0.879. So what will be the mass? It will be 43.95 grams. So this is W1. So W1 is 43.95 grams. Are you getting the same? Are you getting the mass of the solvent? Yes? Okay. Now we have the formula to find the molecular weight of the solute. Okay. So M2 is equals to Kf W2 into 1000 divided by delta TF into W1. So add the factors. Kf is 5.12 into W2 is 0.643 into 1000 divided by delta TF is 0.48 into W1 is what? It is 43.95. Yes. See what answer you're getting? Solve it and see. What is the molar mass of the compound? What is the molar mass of the compound? So the answer, it will come to 156.056 gram per mole. Are you getting the same? So here for the formula, okay, for the formula, correct substitution and correct answer with the unit, you will get 3 marks. Okay, so for the correct formula, for the correct substitution and for the correct answer with the proper unit, you will get 3 marks. Is it correct? Are you getting the same? Yes, are you getting the same? Okay, fine. So moving forward, next question. So this was a question, okay, also from solution chapter. Next question, calculate the equilibrium constant for the following reaction. So just see the question. Calculate the equilibrium constant of the following reaction at 298 Kelvin. So given E naught of the cell is given as 3.16 and this is the cell. Okay, so this is a cell reaction. So E naught of the cell. So we have the formula. We have to find what? Equilibrium constant. Okay, equilibrium constant has to be found out. So how we are going to find? So I'll write the equation. Okay, so that it will be easy for you also. So I'll write it here. So the cell reaction is Mg plus 2Ag plus, okay, aqueous, giving you Mg plus 2 aqueous plus 2Ag. Okay, so E naught of the cell is given as 0.059 by N log of 10 to Kc. Okay, So what is E naught of the cell? E naught of the cell is given. It is 3.16. So E naught of the cell is given. It is 3.16 volts. Okay. Then, so that you substitute, then 0.059. What is N? N is 2. N is 2. You can see here N is 2. Okay. The number of electrons involved are 2. Then log to the that is equilibrium constant is to be found out. So log to the base 10 into Kc. So log to the base 10 into Kc is equals to, so when you substitute this, okay, so divide this and then transfer here, you will get it as 107.1186. So they take anti-log. So when you take anti-log, so when you take anti-log of 100, and because we are removing log, so when we remove log, we have to introduce the anti-log. So Kc is equals to anti-log of 107.1186. So what you will get? See, what you will get the anti-log of that? You should get it as 1.314 into 10 raised to 107. So this is the equilibrium constant, okay, for the particular cell reaction. Are you getting the same? Okay. So moving forward, next one, next question. Next question. The electrode potential for the Daniell cell given below is 1.1 volts. So this is a cell reaction and the Daniell cell electrode potential is 1.1 volts. So write the overall cell reaction and calculate the standard Gibbs energy for the reaction, and Faraday value is also given. So we'll solve this question. Okay. So the equation or the reaction given is zinc solid plus copper plus 2 aqueous, giving you Zn plus 2 aqueous plus copper solid. Okay. So standard Gibbs energy can be found at as minus N F E naught of cell. So what is minus N? N is the electrons involved are 2. So minus 2. Okay, sorry, not minus, the minus. So 2 into Faraday's value is 96,487 and E naught of cell is 1.1. Okay, so what answer you will get? Just see what answer you will get. So you will get it as minus 212271 joules. So converted into kilojoules, it will be 0.227 kilojoules. So this is standard Gibbs energy. Okay. This is a standard Gibbs energy. Are you getting the same? Yes. Okay. Others also, please try to solve this. Okay, very important. So as we have already solved this in our sessions, okay, when we were discussing the particular chapters, but also try to answer your also. Okay. Next question, 48th question. Show that for a first order reaction, T 87.5% is equals to 3 times T 50%. Okay, so this is related to first order reaction. So I solve it here. So what is a first order reaction? So for first order reaction, so first order reaction, so K is equals to 2.303 by T log of R naught by R, right? Now, so at T 387, so they have told 387.5% should be equal to T of 3 times T of 50%. Okay. So we have to show the first order reaction and we have to relate this. So T 87.5 is equals to 2.303 by K, okay, because we have taken this T here and the K rate of reaction here, okay. So log of R naught will be 100. Okay. And R will be what? So 100 minus 87.5 is what? 100 minus 87.5. 100 minus 87.5. It is 12.5. It was 12.5. So is equals to 2.303 K. So 100 divided by 12.5 will be 8. So log of 8. Okay, so what is log of 8? So it is 2.303 by K. Log of 8 is what? Yes, see students, what is log of 8? So log of 8 is 0.903. 0.9030. So time 87.9 is equals to 2 point. So just see 2.303 into 0.9030. Okay, so what it comes? So this into 0. So it will be 2.079 by K. Okay, so this is the first equation we get. Okay, now T 50% is equals to, what is T of half? When T is at half, we know that 0.693 by K. So this is at second equation. Okay, so T of half, what is T of 50% is nothing but T of half. So T of half, we know that for first order reaction, it is given at 0.693 by K. Okay, now what we'll do, we'll divide equation 1 by 2. So next step, divide equation 1 by 2. Divide equation 1 by 2. So T 87.5% divided by T 50%. Okay, so this will be, what is this? So 2.079 by K, okay, divided by 0.693 by K. So what happens here? So K get cancels. So T of, if I have 5% divided by T of 50% is equals to, so do that relation. So 2.079 divided by 0.693. So it will be 3. It will be 3. So we have seen that. Okay, so the next step is what? I'll write it here. Okay, so it is T of 87.5%. Okay, so if I shift this here, so it will be 3 into T of 50%. Is it clear? Yes, is it clear, students? Yes, simple. Okay, so from first order reaction, we are relating T of uh, 87.5% is equal to 3 times T of half. Okay, so this is the problem. Okay, fine. So moving forward, next question, last question. The rate of a reaction increases by 4 times when the temperature of the reaction is raised from 340 Kelvin to 360 Kelvin. Calculate the energy of activation of the reaction given gas constant R is equals to 8.314 joule per Kelvin per mole. So you have to find the energy of activation. So how do you find the energy of activation? Yes, so we have the formula log of K2 by K1 is equals to EA 2.303 R T2 T1 and T2 1. Okay, sorry, again I will interchange. So T1 T2. Okay, so okay, so calculate. So log of K2 by K1. So log of K2 by K1, the equation is 4 times. So log of K is equals to, what is energy of activation is EA. So 2.303, what is R value? 8.314. Then temperature T2, what is T2 is 360. Higher one will be T2 minus 320 and it will be 340 into 360. Okay, now calculate take the energy of activation here on the left hand side. It will be EA is equals to, so what will happen, this, okay, so 360 minus 340, okay, I'll just do, so simple calculation, very simple. So 360 minus 340 is 20 divided by 340 into 360 is 1000 to 400. So it is 20 divided by 1 to 400 will be 0.0001. Okay, it will be 0.0001. So 360 into 340. Yes. 20 divided by that. Or else what we can do, we can keep this as 20. Okay, we can keep this 20 and here we will keep it as like that only. So that further it will be easy for so into 360. So what we'll do now, when we take EA here, okay, 2.303 will go in the numerator. Okay, so into then 8.314 into then log of 4. What is log of 4? Yes, students, what is log of 4? It is 0.602. So this also will go in the numerator because this we are taking in the denominator because A will come here. So this will go again in the numerator. Okay. Okay. So after shifting it to numerator, okay, so that is E naught. So 2.303 into 8.314 into this. So this also will go in the numerator. So 340 into 360 and this will be divided by 20. So do this. Just see what answer you will get. Simple multiplication. Simple multiplication. Okay. Do the simple multiplication first. So multiply everything in the numerator, then divided by the 20. Then divided by 20. Yes, what answer you're getting? Just see. Yes, 2.303 into 8.314 into 0.602 into 340 into 360. So it will be 1410853 divided by 32 divided by 20. So divide this by 20. You will get it as 70542.6. So this is in joules. Converted in kilojoules, it will be 70.54 kilojoules. Okay, so for again, how this marks are divided. So for the correct formula, 1 mark. For the substitution, 1 mark. And for the answer with the correct units, 1 mark. Is it clear? So this is a 70 marks question. So for 70 marks question, we have solved so many, right? So there are many options in each section. Okay, leaving the your MCQs and fill in the blanks. 2 marks, 3 marks, and 5 marks. You have many options. So straight away you have double. Okay, so for writing 3 marks, sorry, for writing 2 marks question. Okay, they have asked to write 3 marks, but they 3 questions, but they have given you 6 questions. So like that, double. So double the questions are there. So you can, for from your choice, okay, whichever you know, you can write any like 3 or any 5. Okay, depending on what the question is given. Okay, so is it clear? Is the so we have solved the complete one model question paper, okay, of chemistry. So any doubts, dear students? Okay, fine. So, okay, so this completes your part. Okay, so my part, sorry. Now it's your turn to put the efforts. Okay, and do well in your coming exam. So I wish you all the very best. So do well. Okay. So if you have any doubts, you can turn up to me anytime. Okay. Okay. Fine. So anything from your side? Fine. So I will end the session here. Thank you. I hope you have understood all the things. Okay. So I'll end the session here. I wish you all the very best.